Okay, cool. Can everyone hear me? People at the back, great, fantastic. Yeah, function F, that's a good idea. Function F, max. All right, cool. Yeah, guys, thank you very much for coming, everyone that pulled out. Thank you also very much to Stockley for hosting these awesome talks. I've had the luck of being to one before, and really nice content, really nice speakers, and hopefully later really nice beer and pizzas. Cool. So I'm just going to kind of get ahead. We had three speakers, but there's this. Yeah, there we go. That's a little bit better. So we had three speakers, although our last speaker pulled out because he didn't make any slides, which is great because I was making my slides up until about 30 seconds ago. Cool. So I'm just going to kind of get started then. Short introduction. My name is Charles. I am sometimes an engineer. I have experience with distributed systems, Rust, and WASM. I work for a company by the name of Zetascale. We're basically a telecoms company with a protocol by the name of Zeno. The goal of this protocol is basically to allow any two devices to communicate over a single protocol. So IoT, phone, cloud, car, toaster, whatever you can imagine, basically. We also have a product called DDS. We're actively shaping software-defined vehicles. And a lot of what we do is open source. So go and play with our cool technology, basically. A little bit more about Zeno. The core is written in Rust. So we have two implementations, one written in Rust and another written in C, which is more to aim at embedded devices. So smaller, a little bit more lightweight, but still full protocol. Full wire protocol implementation. We have bindings to a number of different languages, and we're growing that list as time goes on. Yeah. So, very quick show of hands. Who has used WASM? Hopefully everyone knows what WASM is, but who has actually used WASM in their daily... Okay, fantastic. Who has used WASM outside of a browser context? Okay, cool. That's honestly more than I expected. Fantastic for the three people. So, very quick, who doesn't know about WASM? That's a better question. Okay, a couple people in the back. All right, so very quick 5-second WASM review. WASM, WebAssembly, basically a binary instruction format for a stack-based VM. Originally developed for the web with the idea that, cool, we're going to start compiling C and Rust and C++ code to work in a browser. But it turns out it's actually quite nice to use server-side and not even necessarily only server-side, also on IoT devices and edge devices. All right. Really, really nice in terms, if you were to compare it, for instance, in terms of to Docker, it's really nice in terms of its size. I think a lot of us have experience making these huge Docker images and then figuring out how to cut them down using Alpine images or removing dependencies or X, Y, and Z. As well as the startup speed of WASM is fantastic. So Docker, if you have this huge Docker container, it takes a while to start up. WASM just starts executing. You just give it a function and it starts. Versus bare metal, if you compile something obviously towards x86 or ARM or XYZ, you can't just take it over to a different platform. So WASM is portable. Right. Has anyone heard of WASM system interface? Raise show of hands. Okay, it's the same 3 or 4 people. Okay, no, there's actually a couple of you. Fantastic. So the goal of the WASM system interface, WASI, it's basically a subgroup from the Bytecode Alliance to give WASM some superpowers such that we can have some nice OS level features as well, like access to random access to system clocks, file access, these kind of things. It is independent of browsers, so it's outside the scope of running inside a browser, as well as it does not depend on any web APIs or JavaScript, which will make everyone in this room hopefully very happy. There's a set of proposals for WASM, for WASI. It is being developed as we speak, as in week per week, some new commit has been pushed. And so the spec is still a little bit shaky, as well as the implementations are still coming out slowly. Currently, you can start using it. I wouldn't know whether or not you can actually use it in production, but you can definitely play with it. Currently, these are some of the things that are implemented. And for the future, the WASI working group plans to move towards also including streams and future types for your applications, which is nice in tons of contexts. So why am I saying all of this? Right, this is a WASM runtime. Now, you need to actually run WASM on something in the same way you need to run a x86 executable on an Intel or AMD CPU, right? So there are a couple of different WASM runtimes. WASM Edge runtime is one of them. There's also WASMer and WASM Time, and there's probably a couple of others that I'm forgetting. I think WASMer and WASM Time are the most well-known. WASM Edge a little bit less, but I believe it's going to grow in popularity. Right. So basic idea is you compile your code in Rust or C or Python, if you'd like, to target WASM. It creates a little binary for you to then give to a runtime. This is fantastic. Your runtime can then just start executing your code, right? Your runtime can, in this case, WASM Edge can also execute multiple WASM binaries at the same time, right? They are entirely sandboxed in the same way that WASM in the browser is sandboxed, right? So memory, all of it. Execution is all in a little box that doesn't have any idea of the outside world, of the environment that it's running in, or other WASM executables. One of the nice things about the WASM Edge runtime is that it has a plugin system, which means that you aren't necessarily limited by the memory that you have with WASM, i.e., I think it's 32 bits at this stage. I'm not entirely sure if the 64-bit proposal has gone through yet, but one of the nice things about this plugin system is that you can get some system-level libraries and performances and access to sockets where you wouldn't necessarily get them in WASM. So the idea here is cool. We might have something like an OpenCV plugin that gets us a bunch of functions that we can expose to our WASM application, or an FFmpeg plugin that can now run at system level. This is quite nice because you don't have to actually worry at all about compiling your WASM executable with knowledge of, okay, how do I for instance, get functions from FFmpeg into this thing. How's the performance going to be like? You actually can just use an interface where it offloads a little bit of, I suppose, the effort for the developer. I just know that there's some interface that will guarantee me some function that will work, and I don't really care where it's actually going to call or how it's going to run, because now, as long as my runtime has access to that plugin, I know that I'm going to have access to those functions. So this is kind of like separating a little bit more the concerns of the developer just knows that there is an interface and it's guaranteed to work. The DevOps guy will then have to go and say, okay, cool, let me figure out how I can set up my runtime with the correct plugins and the environment such that it all works, such that the expected contracts that I basically have in my WASM binary or my SDK will be fulfilled. Right, so it's quite a nice model. It changes it up a little bit, and I think it's quite portable, basically. That's the end of that slide. Cool. So why am I even doing this talk? The TLDR of it is there is a company by the name of Second State. The CEO is a guy by the name of Michael Chuan. I've butchered that pronunciation. I do apologize. They have this project, WASM Edge. They own the repositories, and they manage all of the open source of it. It's an open source project, by the way, WASM Edge. So they are part of, or WASM Edge, I suppose, is part of the Cloud Native Computing Foundation, which is a group under the Linux Foundation. They had a mentorship a couple of months ago open for anyone that would be interested to contribute to this environment. And they had a couple of different plugins and tasks and things that they wanted to have built, basically asking for people to get involved, right? I've always wanted to contribute a little bit more to open source, as well as get involved in computer vision and Rust. So basically, the project was born. A Rust crate for the YOLO family of object detection models. So very quick show of hands, who does not know what YOLO means? Outside of the Drake song, of course. It was Drake, yeah. All right, cool. So YOLO stands for You Only Look Once. And the YOLO family of computer vision models are a family of computer vision object detection models specifically that are single shot. So you don't have to run multiple passes through your net in order to do object detection. They're super powerful. I don't know if they are the fastest. I think they are the fastest. I'm not sure if they're the most accurate. It's usually either you're the fastest or you're the most accurate in terms of object detection, not both. But they're super, super popular for real-time applications because of their speed. And they recently released version 9 of their implementation. The first version came about many, many years ago. So super cool. So basically the idea is we want some sort of crate such that we can support loading and running these models in the WASM Edge runtime in a context for our WASM applications. Awesome. The scope of this project, right, is to do the pre-processing of an image, because we can't just take the bytes of an image and throw it at a neural net and expect it to know what to do with that. There are no neural nets training involved in this project. Basically the pre-processing, the post-processing, and support for image and video was large enough in scope to keep me very busy for the period of the 12-week, I think it was, mentorship. It was a mentorship that I did in between jobs, and I was worried I was going to get bored, so I basically started applying for these things like crazy. There are no neural nets that I have done personally, right? So the idea is I just basically get a trained weight file, I load it into the application, and do a forward pass with the pre-processed byte stream that I basically have. The project structure is basically a WASM library, an SDK for developers to use, as well as a video processing plugin for the WASM Edge runtime, right? In this video processing plugin, I'm using FFmpeg under the hood because it is basically the backbone of all AV today. Whenever you see something on YouTube, it's actually just a client for FFmpeg, realistically. It is online. It is called WASM Edge YOLO RS. It is very much still a work in progress. I am going to caveat that right now for the reason that during this period in between jobs, I decided to move countries and start a master's degree. So I haven't had tons of time, but I do plan on, it's usable, but there are lots of issues with it in terms of performance, in terms of cleanliness, in terms of a couple of unwraps that I still need to handle. But it's online, you can play with it now. Just don't expect it to work 100% now. Cool. The basic flow for this is load the image into our WASM runtime, pre-process the image, forward pass through YOLO V8, post-process the image, and don't ask Satya for $7 trillion, but rather do something with the inference results. So this is the kind of idea. Pre-processing, cool. So the first step, a neural network expects some sort of shape. So we want to load in the image, we want to resize whatever image we have, we want to maintain the aspect ratio, all right? So also very important, the version of YOLO that I'm using is V8, all right? And I don't remember which specific sub group of V8 I'm using. I know there's like a small, a large, and extra large that offers differences in terms of file size of the weights, as well as speed, as well as accuracy. I think I was using YOLO V8-M or L or something along those lines, but YOLO V8, right? Super simple processing, pre-processing, something that you can basically just use Rust's image and image proc libraries to do, and I'm going to show you exactly how we do it. So this first image is courtesy of the Reddit user Nguyen Dees. It is an S-tier battle station, of course. Very good. I just skipped a couple. So first thing we do is resize this to be 640 by 640. Now, on my monitor with decent contrast, there is a large black bar at the bottom of the screen. You're going to have to use your imaginations. Next time I will put a border around the photo. Next step would be to split the image into its individual RGB channels, right? This is actually quite a nice image to, okay, again, no contrast here, never mind. It's a nice image to show it just because you can see how green contributes to certain parts of the photo, whereas red does not, but you see red contributes to bugger all with this terrible projector. Once you split into channels, you basically have a set of ones and zeros that you now need to deal with. You can think of this as a matrice of 3 matrices. What you want to do is actually convert first to F32 for the reason that the neural network is expecting floats of 32 size. I think you can use, I'm fairly certain you can use 16 bits and even 8 bits with other neural nets, but this one specifically was expecting, or the weights that I loaded was specifically expecting 32s, F32s. Then you flatten them down all into a single buffer with all of the red pixels, all the red floats pixel values first, the green second, and the blues third. So what does this actually look like in code? And it's not super difficult, really. So we start with the first part, which is going to, well, we can load in all the libraries, of course, but we start with the first part, which involves actually doing the resizing. Now we want to maintain aspect ratios here, so we need to find the longer side, and we need to find the shorter side, and we make the longer side equal to the 640 and the shorter side equal to less than the 640 to maintain that aspect ratio and make sure that whatever our zebra doesn't become like a squashed zebra. Specifically for this, when I was using image proc and image to library, I'm not sure if I couldn't, but I found it easier to actually just allocate an entirely new image of the correct dimensions and then just copy from the old resized image down to the correct aspect ratio, except fitting into a 640 by 640 box into the new byte buffer basically for the correct image. So that's how we get the black bar at the bottom. Then we split it into its red, blue, and green channels, and I'm compressing two actions basically here in one, where I'm splitting into it, I'm iterating over every single pixel, splitting it into its red, blue, and green channels, and then converting it to floats, right? Finally, we have our red, blue, and green channels, and I basically just flatten it down from a vector of vectors into just a single vector of F32s. Yes, correct. And then we just return basically this wonderful vector that we have of F32s, of RGBs, and in this case, a scale size. So we are going to run this through a network, and we need to know how to scale up our results to fit the original image. Because remember, we want to actually paint this on the original image and not the scaled down version. Cool. So now this is ready for our neural net, which is great. So this next part, we utilize something called WASI-NN. There is a crate for it on crates.io, waiting for you guys to play around with it. And any runtime that is compatible with WASI-NN, so it has the standard implemented, will be able to make use of this crate, basically, in the WASM executable that you compile and run in that runtime. Okay, fantastic. I got that sentence out, guys. It's great. Cool. The crate's name is WASI-NN. I'm using 0.60 here. Really, really high level and super simple. And this is one of the things that I quite like about using WASM Edge and WASM runtimes for kind of abstracting away a lot of complexity from the developer. Here, I'm basically just importing an execution target, a graph, or like a structure that represents a graph, and a graph encoding. So it's as simple as you read in a bunch of bytes, which represent the model file. You create a graph. You tell this graph, okay, this is going to be of type PyTorch, or the weights are going to represent PyTorch weights, or Onyx weights, or Keras, 100% was the other one. And then you set an execution target, which is actually quite nice. It's really high level. You don't have to worry about, hey, is this running on NVIDIA? Hey, is this running on a Jetson? Hey, is this running on XYZ? These two enums represent currently all of the supported execution targets and graph encodings. OpenVINO, Onyx, TensorFlow, all of these great things. I'm looking forward to safe tensors personally, because I think it is one of the better formats, or maybe I'm just a fanboy. As well as you have this execution target, which is quite nice because you can say, cool, I'm going to test this all on my CPU, but then when it comes to actual D-Day production, we just tell the DevOps guys to rather pass in GPU and hope that they set up their WASM Edge environment correctly, and we don't get a bunch of, hey, your NVIDIA libraries are missing everywhere, or your TPU if you have like a Coral or something like that. Now the code, really that simple. You have set up your graph already, like that with that graph builder that we were showing a little bit earlier. You initialize your execution context, then you set your input. First value, I believe, is because you can have multiple executions running at the same time. Second input is your tensor type, in this case F32. Third input is the shape of your tensors. I don't remember offhand exactly why there's a 1 in front of here, but the 3 input width, input height basically tells us how many channels we have, RGB. Input width and input height is the size of our image, and then we just give it our tensor data. Then we basically need to allocate a buffer for all of our output, which in this case is also a buffer of F32s, and the buffer needs to be the size of objects and our classes. We basically say compute, and then we get our output, which is great. Yeah, and then I have animations to say exactly that. Okay, I'm going to have a quick glass of water before starting post-processing. Okay, cool. So with respect to post-processing, we get that buffer of outputs, which is, I thought I changed this. Well, that's what you get for doing your slides 5 minutes before. Anyway, you get basically a buffer of outputs, which represents all of your classes and your number of objects, all right? You do, in terms of the post-processing pipeline, you need to apply a non-maximal suppression to your outputs, specifically YOLO V8 and other object detection algorithms, I'd imagine, or other object detection models, I would imagine, as well as then a reduce. So in this case, an intersection of a union. I'm going to go through what all of these things mean. And then you're left basically with all of your detections, your classes, and the positions in the image. So the output for the neural net is going to be this buff of F32, which is going to have the shape of objects and classes. Technically, it's going to represent objects and classes. Objects are the number of detections we get per image. So you take an image, you run it through YOLO after doing all the pre-processing, you get out 8,400 detections. You have 80 classes, specifically for YOLO V8, that you can represent. I'm not sure if you can do more or less. I just remember that it was 84 in my case, or 80 in my case. And then you get 4 values that represent X, Y position, and width and height as to where in the image this detection was made. So one of the first things we need to do is process this buffer, which is going to be represented as a vector of floats, right? So we chunk exact this buffer into, so yeah, it comes out basically in this wonderful format of x1, x2, x3, and then we have x84,000, y1, 8,400, I can't numbers this evening, y1, y2, y, so on and so forth, the width 1, width 2, and then all the class, the height 1, height 2, and then all the classes, all the detections. So we basically need to do just a little bit of matrix fumbling to get, not fumbling really, but matrix formatting in order to get it into the shape that we actually wanted. This code is literally directly copied from the repository. Yeah, this is exactly what we had to do. Cool, what I had to do. And once we've done this transpose, basically at the very end, into a nicer format, which is a 2D vector, or a 2D array, I suppose, of all of your detections, as well as the number of classes that you have. So every row would be its own individual detection, and the columns would be X, Y, Z, X, Y, width, height, and then all of the different detections that, all the different class probabilities that you have. Because remember, neural nets basically say, cool, I'm going to try to detect all of these things at the same time with 80% certainty. I think that this is a zebra. With 10% certainty, I think this is a sheep, or something along these lines. So this is basically the output that we get, exactly what I said, X, Y, width, height, and the probabilities for each of the classes, of which we have 80 of them. We apply non-maximum suppression, which basically just looks like filtering everything that does not meet our threshold, right? So we have some sort of confidence threshold that we pass into our program saying, okay, I don't really care if my object detection is, if I've detected objects that are not at least 95% certain that this is some object, a car tire or a vehicle or something along these lines. So let's just filter all of these guys out immediately. This involves us basically iterating over this list, finding the maximum element, saving it, and continuing with the program. Oh, okay, this is a big one, right? Cool. Just continuing if the maximum threshold, if the maximum found is less than our confidence threshold, and then basically getting the actual class in all of the possible classes. Remember, we had that list where the first one might be a 20% likelihood or happiness in terms of its detection probability. Second one might be a little higher. Third one might be lower, something like that. So we need to basically find the index in this list in which we have the highest likelihood to be the correct object. The output. Okay, cool. Then we need to obviously take the first couple of elements out of that list to get the X, Y, width and height of where this detection was made in the image. So in this case, it actually gives us the center of the image. And so the reason that we have this 0.5 minus 0.5 minus is such that we offset the width and the height, or the x and y, such that it's not in the center of the image, but in fact at the top left of the image, right? And then we just have our width going to the left and our height going all the way down, and we have a bounding box for our image. And then we basically just push our results into some type that we have that represents a bounding box, the confidence, and which class we have detected here. Bus-Pursued array is also in here. Fantastic. Right. Okay. So. Oh yeah, we have applied an IOU. Fantastic. This is what I was looking for. So after that, we want to do something called intersection over union. So what this basically means, and I should have added a nice graphic here, is when doing object detection, you are going to get many results in the same rough neighborhood, 1 or 2 pixels offset from each other. And we don't necessarily want to have each of those as individual results. What we would rather do is say, okay, we know that with high confidence or high certainty that there is going to be an object around this area. Let's just find whether or not these detections overlap enough such that we can bound this all to a single object, or whether or not we actually have 2 objects, or what exactly is our how this image actually wants to be represented in terms of is it 1 object, is it 2 objects, is it multiple objects? And so the way that we do this is basically by implementing something called intersection over union, which is nothing more than taking the bounding box of one detection, taking the bounding box of another detection, getting the areas of both of them, and then getting the intersection between them, and getting the intersection over union, which I don't know if we can see the entire code here. Is there a way that we can scroll? No, we cannot. Okay, fantastic. To basically get some metric by which we are certain that there is actually a single object here and not multiple objects. So if they are slightly overlapping, then we might not be very confident that it's a single object and that it's actually in fact 2 objects. If they're very much overlapping, i.e. have a high amount of overlap, then we're certain, cool, we actually just have multiple objects with high confidence around the same object, which is great. With multiple detections, around the same object, which is exactly what we want. There is a vectorized version of this. I first implemented a non-vectorized version, and then I implemented a vectorized version. I got the vectorized version from this really nice RoboFlow blog by Piotr Slazkalski. Sorry, I'm terrible with Russian names. So I would really recommend reading this. It's super well written. It has really nice infographics as well. It is written in Python. It's using NumPy. So in my version, I was obviously using Rust, and I think I was using ND-Array, if I'm not mistaken. We're about to find out. So I'm not going to go through all of the code because there is a little bit of complexity to it, and there's a couple of things, not because of the complexity, but there's a couple of things that come afterwards in the talk that I do want to get to, that I think are a little bit more important. But the one kind of gotcha, or one thing to watch out for if anyone wants to go and attempt something like this, is specifically in Python, arrays are broadcasted silently, which means if you have 2 arrays, or 2 matrices, that you need to multiply with each other, and they are not of expected sizes, i.e. you have that makes sense to multiply specifically. So if you have, like, let's say a 1 by 90 multiplied by a 3 by 4, you wouldn't be able to do that actually. So what Python does is it just silently extends the dimensions of one of the arrays and does the multiplication, and then you're just left with this silent garbage. So in Rust, thankfully, the garbage is less silent. You still have to do this array broadcasting, but in Rust, you specifically have to be explicit about it, and basically call this .broadcast function in order to extend the dimensions of one of your arrays. In this case, if it cannot figure out how to broadcast an array along a specific dimension, because remember, we are dealing with arrays that can be n by n, n by m, by x, by y, by whatever, in terms of the actual number of detections, as well as in terms of the depth of the array. We can throw an error here saying, cool, we can actually do this. Hopefully this error should never pop up if the code works, but it's still here as a safety mechanism to let me know that I've made some sort of other mistake in the code. Actually, it's kind of funny because a couple lines down, I'm unwrapping and not doing this, so it's something I have to go and fix. And the output looks like this. So we have our awesome battle station, and we've detected some objects, which is great. So after the previous step, after we've done our IOU, after we've set our threshold for confidence, which apparently is quite low because it's only 52% sure that this is a pot plant and 64% sure that this is a TV monitor or a computer monitor. We actually have our nice object detection. I didn't actually even see the Herman Miller in the corner there, but it managed to see it, which is fantastic. I don't know if this is small enough for you guys. I can make it a little bit smaller if you'd like. So yeah, we have our output. I wanted to very quickly discuss a little bit of the actual plugin interface, because I did say that there were two parts to this project. Number one, the SDK specifically for the developer that is going to be writing their WASM application and calling into. And the other one was the FFmpeg plugin that we're going to be using to process video specifically. So at a very high level, because this was the part that I was doing 5 minutes ago, at a very high level, we basically have a set of functions in which we can call from our WASM executable to basically pass data to our plugin, all right? These are very C style, as you can see. I'm going to start passing pointers and numbers all over the place and really hope that these pointers and numbers work out. It is dangerous, 100%. It is on my to-do list to use a project called Stabby, actually created by Pierre, to see if I can make this a little bit more safe in terms of having a more typed interface rather than, hey, here's a bunch of function pointers, kid, go shoot yourself in the foot. So yeah, this is basically very high level. It just loads a video into memory. It splits out the frames using FFmpeg's Rust bindings. It presents to WASM all of the frames one at a time. I think it's literally a read. WASM then goes and does the inference that we just spoke about, and then delivers to the video processing plugin the frames again. Then the video processing plugin handles actually assembling the frames into a single set of AV frames, and then writing out the packets, writing out and encoding the packets back into a file on your hard disk that you can use, or a file that you want to now send over the network or whatever. Cool. So I have a video example of this. My friend Snehil said that he wasn't going to be here, so I thought that maybe we should actually just use the video example of him in the office doing exactly this. He wanted to hide his identity, and so, sorry, Snehil. But yeah, so this is basically it running with an actual video. It works. Kind of surprised, guys. No, it does work. In terms of performance, it is very, very far away from being optimal. There's a number of things that I need to fix and improve with respect to performance, which I am going to get to once I do better in everything else in my life first. But I do have some plans to continue this project in due time.
Is it real time?
No, God no. Oh. I mean, if your real time is 1 frame a second, yeah, it's real time, 100%. No, I did mean to go and do some actual measurements in terms of performance, but I don't think we're anywhere near real time at the moment. I believe because everything is now system level, and because if you have NVIDIA drivers underneath actually doing the heavy lifting, and you have the right codecs and everything, maybe we can hit real time. I haven't measured, so that's my big caveat right now. Listen, the code is open source, so you can tell me. Also, 2 things. So, all right, okay, cool. So 2 very important things. There's 2 things that can run here on an accelerator. That is not a CPU, because it's not really an accelerator, but 2 things that can run here on a GPU. Number 1 is the video processing done by FFmpeg. And that's quite simple. You basically need to compile FFmpeg to use NVEC, which is the encoder and decoder specifically offered by NVIDIA. And the second one is the actual running of the neural network. I am doing the NVEC decoding and encoding via NVIDIA, or via the NVIDIA codecs. I am not doing, I don't think, I'm 90% sure, 99% sure that I'm not doing any neural net stuff specifically on my NVIDIA card yet, just because I haven't played around with it so much. I got the CPU version working, and I was like, cool, I'm done, guys, I'm happy. Cool, yeah, so I think I explained this a little bit earlier. It's not super complex, but it's basically just load video file, process encoded packets into RGB frames, run inference on each of the RGB frames, return to the video file, return to FFmpeg all of the frames, which would then encode into packets, which then write packets to disk. One of the fun learning lessons that I had is that video encoding is hard. There is a lot to it, and it's really flipping interesting as well, actually. So a very quick TLDR of how videos are not huge is we basically have this idea of iframes and v-frames. I forget which one is which, but one of them is basically a full RGB representation of the image, and the other one is basically just a diff effectively in time between the last full RGB image and some timestamp, right? That might be a diff of diffs, but it might be just a diff if, for instance, the image stays, or that specific pixel or that specific region stays the same color as before, right? This was super interesting, and it's one of the reasons that we just don't have huge videos. I am not doing this correctly in my program, and I have spent many nights trying to get this right, and I suspect that I'm using either an older version of FFmpeg, or I don't understand entirely how to use the Rust bindings to FFmpeg. So if we have any experts in the audience, please God, I'm looking for pull requests. But the TLDR is, if you input a wonderful 4 megabyte video, I'm more than happy to give you back an 80 or 90 megabyte completely uncompressed video, guys, free of charge. Yeah, 100%. So I'm using NVEC under the hood, and I'm using a 3070 on that laptop over there. Did I have another slide? No, that was it. Learnings, cool, yeah. So the biggest takeaways is that broadcasting of arrays in Python is silent and it sucks. FFmpeg, iframe versus bframe, as well as encoding in general, super damn interesting. Utilize your NVIDIA card if you can. It'll speed things up quite a lot. Or your non-NVIDIA card. Hoping to see more Zluda in the future, as well as I need to actually continue this project and use the latest version of FFmpeg, so I'm not dumping out massive files. Yeah, so that is my presentation, guys. Thank you very much for my talk. Can I avoid questions, or does anyone have any questions? Yes. One, I think, at the back.
I hope everyone will hear me. Well, thanks for the presentation. It was very interesting. I actually have a couple of questions.
Okay.
The first one is about this intersection over union. Isn't it something that is already implemented in YOLO so that you don't have to implement it yourself in the code?
No, unfortunately not. So when I got my... Hello? Yeah, there we go. So unfortunately not. When I got all of the when I got the output from my forward pass of YOLO, I looked at some of the results, and often I would find bounding boxes that were offset by literally 2 or 3 pixels in other directions. And then when I just tried to print them on screen, just draw bounding boxes to screen, I'd have this mess of text and this mess of rough area of bounding boxes. So it's something that, at least for the weights that I had to do myself. I could be wrong, but I'm 90% sure the first time that I actually printed an image to screen, it was a mess of really roughly the same area of bounding box for a single image or single detection.
I think it's worth taking a look at that, because I read the YOLO V3 paper, or V2, and the IOU was actually part of the pipe of YOLO.
Okay.
So I don't know what happened in between V2 and V8. Maybe they removed it, and then you have to do it by yourself now.
No, I have the. It's actually in the library YOLO. If you use the library YOLO, you have the NMS direct unit. But actually, the neural network doesn't produce there is no part in the neural network that does the NMS.
Yeah. So for everyone watching at home, there's no part of the neural network that does this, but using the YOLO library, it's easy, and it does it under the hood, I'm assuming, silently. So if you just load the weights like I'm doing, unfortunately, you just get raw neural net output, just some bytes, and go and have fun, kid. Next question.
Well, it's about the same thing.
Okay, cool.
Can you go back to the execution provider? Graph thing with when it and stuff.
The execution. See, it would help if I actually had any idea where my slides are. Here?
Yeah, this one.
This one. Or one better.
Just after,
yeah.
So which one of them are you using?
The execution target, I'm using CPU for now, and that's the reason. Graph encoding. I'm loading in PyTorch weights, if I'm not mistaken. Yeah, I'm 90% sure it's PyTorch weights. It's something that I think you can pull off of Ultralytics, and I think they have in their releases, they have a bunch of assets that you can just pull medium weights, small weights, large weights of YOLO V8, And if I'm not mistaken, I'm pulling those and just loading them directly.
You can just look at the previous slide.
I can, that's true. I don't know which previous slide exactly. The one with where I have this thing, I think.
Yeah, so basically, when you're loading a PT file, it's not just the weights, it's like the graph with it. And I have like
I don't have this anymore.
a modified YOLO repository. I could show you where the NMS is actually within the torch graph.
That would be awesome, actually. That would save me a bunch of Rust code. If it's performant, super keen to use it. It's probably more performant than the stuff that I wrote, so very keen to chat to you about that. Any further questions? Okay, crap. Yes, go for it.
Yeah, really quickly, simple question.
Hit me.
Just wondering about your experience with all of this, because this was a lot in 3 months, right?
This was a lot in 3 months.
So yeah, Rust, Wasm, Wazi, all of that. Did you have fun doing it?
Oh god, yeah, I had tons of fun doing this. This was probably, I think, my girlfriend didn't have fun. My ex-girlfriend at this point didn't have fun with me doing this. There were many nights where she was not chuffed that I was behind my computer monitors. No, I did have a lot of fun. In terms of experience, I had a fair amount of experience with Rust. The previous 3 jobs that I've worked on production Rust, which is awesome. I didn't have experience with computer vision specifically, and I was also lucky to have a little bit of experience with Wasm. I wrote a tutorial 2 years ago, I think, to use Wasm and WebRTC on the web or something like that, and it was just like a Rust, specifically in Rust, so it was like something that you can just run basically on your browser. I'm not sure if it still works now, but computer vision, 0 experience, Wasm, a little bit of experience, Rust, a little bit of experience as well. We're still learning. Yeah. Next question, someone, yes, hit me.
Sorry, I'm not done yet.
Let's go, come, another one.
So regarding the matrix multiplication, I mean, generally speaking, operations, this is something I didn't know at all. Is it a Rust credit, or is it something native, or is it something like NumPy, or is it something native supported by Rust?
Can you just repeat, sorry, the question one more time? I missed the beginning.
All the matrix operations you have performed.
The metrics metrics operations.
Yes.
Matrix. Oh yeah, 100%. So is that a Rust crate you're asking?
Yes.
Okay. Regarding the matrix multiplications and everything that I've used, yes, it is. I'm using NAlgebra to do it. So I'm offloading all of my work to NAlgebra, and because NAlgebra can compile to Wasm, I think I'm even doing it inside the Wasm binary. I could probably do it inside the plugin for the video processing. Would I want to? I'm unsure. I will think about that after this.
Okay. And last question.
Hit me. Go for it.
So regarding the Wasm plugins that you presented at the beginning of the presentation, so if I understood correctly, it's an offsite plugin, so it's running directly at system level. It's not running through the Wasm, I would call virtual machine.
Correct.
So then you need a plugin compiled for each type of architecture that you use. If you're running on an ARM or x86 or x64, you need to have a plugin version binary compiled for that architecture, right?
100% correct. So I'm going to repeat the question. Basically asking specifically about these plugins. They are not running in Wasm. No, they are compiled to x86. They're compiled to ARM. They're compiled for whatever platform you're running on. And you do need to have a separate version for every single platform. You are 100% correct in that, yeah. One of the benefits of using plugins is that they're not limited by whatever the Wasm proposal is. So in terms of 32-bit integers, or you don't have 64-bit numbers, for instance. So the memory space, they are unlimited. You can load whatever you want in them, and your limit is technically the system memory, which is great. So super powerful. In terms of performance, I haven't measured, to be honest. There was another
very quick question.
Hit me.
It's actually an extension of the same question. So I guess for the WASI NN, it runs on the runtime, so there is an overhead of interpreting the Wasm code. But for GPU offloaded, let's say we have the model and we run it on a GPU. What is the overhead of running it in Wasm Edge versus running it on bare metal on the GPU?
Oh, that is a great question. Next question. I'm actually not certain. I'm not certain as to what the overhead is. I haven't run it through WASI NN with an execution target other than CPU. I think I may have tried at some point. But I also wanted to finish this project to a reasonable level of at least ticking the boxes in terms of what I needed to produce before the deadline. And so it is the next step. It's actually something that Michael Juan has been asking for. And so I will at some point get around to it, but it's the next step. Yeah, go for it.
Yeah. What's the difference of the different runtime of WASM?
The difference of the different runtime of WASM, that's actually quite funny. I was creating a slide to compare WASM Edge to WASMer to all of these others. And then I ran out of time, and so I didn't create the slide. I don't remember off the top of my head. I think WASM Time is owned by the Bytecode Alliance, which is the working group that is actually responsible for WASM as a spec. I haven't compared the runtimes, to be entirely honest, so I can't answer that in confidence.
You don't know the reason why
they decided to make one or the other. Off the top of my head, no. It would have been a great question that I had 12 weeks to ask and I didn't take the opportunity to. Yes. All right. Any other questions, or can we let Pierre speak? Please. All right, cool. Guys, thank you very much again. That's looking right now. I think I'm ready to smoke.
45 minutes.
45 minutes on the dot. Yes! Oh, that was fantastic. Okay. Yeah, this is question that's probably Okay. Hello.
Hello everyone. Before I switch tab, can we turn the lights on? Because we're not vampires, but we're going to feel like some.
I need some light. Does anyone know where the light switch is? We have a room full of people that push buttons for a living. Surely one of them the only button in this room.
Where's the correct button, please? Because there will be a lot of sunlight once my talk gets on the screen.
Yay, now this is safe. Chrome, if you would please stop being stupid.
Alright, I guess we're doing that with my IP on the slide for the whole time.
And if you go twice,
It just, yeah, there we go.
There we go. All right, go.
Yay. So now is the time that everyone that found Charles' presentation too complicated can wake up, and everyone that liked it can go to sleep. Because for once, I'm doing a presentation that not everyone's going to get headaches after it. I'm just going to tell you how to make crates that are production ready, that people are going to actually want to use. And the reason I'm saying that is that we don't like, there's a way of doing crates we'd like to be. What we'd like is to just write the crate, write the code, debug a bit, make sure there's no bug, pick a name, upload it to crates.io, and just watch as the count goes up and up, and we become super popular, and that's great and all. But generally what happens is we write a few thousand lines of code, we press cargo publish, and there's like 12 downloads. And I can assure you all of them are docs.rs bots. And it is a very disappointing experience. So I'm going to try and help you get a bit more downloads. So who's this guy trying to tell you what to do? I've been doing Rust professionally since 2018. My name is Pierre Vital. I work with Charles at Cityscale, and I'm a core contributor to Eclipse Zeno. He just gave you the run on it. It's a super cool name data network framework. It runs on anything thanks to our C implementation. It can do Bluetooth or IP, kind of everything. It is super cool. I'm also making a name for myself right now writing Stabby, which is a stable API for Rust, and also kind of a alternative for the standard library, which is API stable. I've done 2 talks last year about it, one at RustConf and one at RustLab. There will be QR code links about it on the end slide. So the main reason things tend to go wrong in download counts is that this is my recent experience. I needed a parser. I needed a parser to tell me where the things I had parsed came from. So I looked at parser on Crates.io. I found Combine, looks super cool. And then this type showed up. The thing is, it didn't work either. So to Combine's credit, they actually have a ton of downloads. They're actually super popular, and they actually made something super cool. But I ended up writing my own parser because it was simple and trying to understand what they did. And that is something that can happen a lot if you don't do documentation. So document the things, and basically this talk is mainly an excuse to tell you about the lengths. So the first one you should always turn on, this is one of 2 lines of code there will be in this talk, is deny missing docs. This is something you should have enabled, and here are a few more lengths that you should enable today. Yesterday would be better. So my favorite length of all is missing panic doc, because Clippy will actually figure out whether or not your code can panic and tell you you have to add a panic section to your documentation. This is super helpful. Missing safety doc basically just goes, you made an unsafe function and didn't tell your users how to use it safely. Please do. Its little friend is undocumented unsafe blocks. This basically just tells you, please make a safety comment every time you write an unsafe block, which is something you should already be doing, and please make it right. The goal with that is 2 folds. One is to make you think about what you did with unsafe and how you probably got it wrong. The other goal is to make it more annoying to write unsafe code so that you stop doing it. And finally, because we already have a lot of missing X docs, it's the same for errors. So it's going to ask you to write an error section if you have a result as a return type. This lint actually works a little less than the others. It's not as good as figuring out whether your thing is an actual result or not. And when you have alternative result types, it might not figure it out. But it's nice anyway. It makes your documentation consistent, which is a great help in acquiring users. So now I'm going to talk about the things that you do that contaminate your users, and therefore they might not like you anymore if you do them. Unsafe is actually super hard to get right. People tend to say that unsafe in Rust is just doing C. No, it is much harder, because the moment you have 2 mutable reference to the same thing that exists in code, Rust is allowed to consider that this code does not exist, and that anything that would have led to this code does not happen. So if at some point in your code something could make 2 mutable reference to a same object, Rust is allowed to think that a function that returned a boolean that led to this code will return false every time. The optimizer will do very funny stuff, and it will fuck you up. So the other thing is that you probably don't need it as much as you think. A lot of people go, oh yeah, but there's bounce check on arrays and all of that. I don't want that. I want to use unsafe so that I don't get my bounce check. Don't worry, Rust will get them. If you code properly, most of the time you won't actually have that many bounce check, at least not ones that you shouldn't be doing. So please don't use unsafe unless you're really sure you need it, either because you're doing something wonky or because you know the optimizer is not catching your case and you know your case is a correct case of optimization. And finally, if you do use unsafe, please use Miri. It isn't that bad to use. It's basically just a runtime to run your code in that will just pop up exceptions when you do things you shouldn't have been doing. Remember, undefined behavior doesn't mean it's going to run a certain way. It just means the compiler is allowed to do anything with it. We've gotten to use, thanks to C and C++, to undefined behavior being actually implementation-defined behavior, and then relying on it. I've seen many people relying on the fact that if you do malloc and you look a few bytes before, you'll find the length of the allocation. You shouldn't be doing that. But it's become so standard that people actually do it and consider it correct to do. Undefined behavior is not that. Undefined behavior means the optimizer is allowed to consider this shouldn't happen, and therefore it can optimize everything that makes this happen. On to testing, because that's something your users will like a lot. TDD is actually super nice to do. It's basically so TDD test-driven development. The idea is that you first write your test, which forces you to first write your interface. So it's actually super nice to do. It's especially nice if you find someone else to write the test for you, and then you do the implementation. But it's actually a super fun way to work once you get into it. So it's a mindset. Some of you will like it. Just try it at some point. Property testing is super cool. So there are crates like PORP test. The idea is that you encode your contracts into your test, and then you let the testing framework decide what input to test with. And ideally, the framework will get very good at finding the smallest input that will fuck up your code. So it is super nice to use, and I would push you to introducing prop tests into your code. And finally, doc tests are great at two things. They're great at being tests, and they're great at being specs. And there are a few ways that you can use them. The standard way is to just make a block of code. If you make a block of code in documentation in Rust, it becomes a test, which means you can check that it compiles, and you can check that it doesn't panic. And it's also a documentation for your user. Super great. You can also make sure that it doesn't run, because maybe it's doing API calls and you don't want your tokens to get destroyed. Or maybe you want some code to actually fail. Like if you're writing a crate like ghost token, where you actually want to prove to your users, hey, this crate will not allow this thing to compile because it shouldn't. Well, you can have tests to prove that it doesn't compile. Should panic basically does the same thing, except runtime. And if you don't want all your documentation to become code, you can just put a pound sign in front of it and it disappears. Finally, benchmarks. They're basically, there are a few popular tools to do them. Criterion is super flexible. Divan is a bit more comfortable, but I haven't actually used it much because I like the flexibility of Criterion. The core idea with benchmarking is that it is actually hard to do. You can't just loop on a thing and time it. It is not going to give accurate results. You have to think of your use cases. You have to think of what you should benchmark before you actually benchmark. Just running a thing in a loop generally isn't a good proof that your thing is fast. And I would advise you to be hard on yourself when you do benchmarks. It's nice to have benchmarks that say that you've been a genius and done something super fast. It's even better to have a benchmark that tells you you fucked up and you need to get your code better. That's usually the ones I like most, because that's the ones that then you can improve and you feel like it's a video game. So be hard on yourself. Do benchmarks that try to find the stuff that you messed up, rather than do the ones that prove that you're good. Finally, I'm going to tell you about a talk that it will traumatize all of you. It's called Performance Matters. It's by Emery Burgess. And basically, this talk will show you a super cool thing that is called causal profiling, which is great at actually improving performance. And the other thing it will show you is that by changing your environment variables, you can actually affect your performance by 15%. And this is the moment where suddenly you think, wait, why have I always been grabbing 2 or 3% thinking that's going to save millions to the company because we're going to spare RAM and CPU time? And then you realize, oh, changing an envar can actually yoink 15%. The fuck? So yeah, go check out this talk. It's actually super interesting, and it has a much better view of profiling than the average one. And the other thing that can affect your users a lot is panicking. Please don't panic. Panic is bad for multiple reasons. One is it causes crashes. No one likes crashes. But the main reason panics are bad is because not all platforms actually want to unwind. If you're doing embedded, you will abort on crashes, which means you won't do the cleanup that the fact that we have RAII supposedly guarantees. So panicking is bad. Ideally, you should avoid it by doing results if you know your operation is fallible, and you should only ever panic if you are in a state that you do not ever want to try to recover from. And if you do use missing panic stocks. It's going to tell your user that you can panic. It's going to tell you that you can panic. It's actually super helpful because sometimes your code can panic and you're just not aware of it. So this is why I love this lint. And it's going to basically tell your user, if you're doing embedded work, just don't use this function. Use the one that use the alternate that you hopefully made that doesn't panic. And finally, one thing that contaminates your users a lot is STDs. Oh God. So ideally, when you make a library, you should be thinking, okay, I have core, which is the actual core library for Rust, which has your primitives and a lot of your traits from borrow. All of these are actually from core, not from STD. And then you go and think, yeah, I need a hash map. I'm going to need a lock. And then you might think, okay, I need a mutex, I need a file system, I need all of that. I need a supported OS. I need the standard library. But ideally, that should be your frame of mind when you're doing a library. You shouldn't just use STD because that's the default. Because when you do use STD, you basically ban all your potential embedded users. The way I advise you to remove STD from your crate is using a feature and using an additive feature. Do not do a no STD feature because the moment one of your importers imports you with no STD, that means your user can't import you with STD anymore.
There's also another case. If you import something with STD, you can import it with core instead.
Yeah, it's actually a great one. So the remark was that Clippy can also tell you that you've imported something from STD that you should have imported from core. And if you need allocations, the way you enable them is with external crate alloc. You can't unfortunately go alloc in the cargo toml, which is something that I would like a lot more because it just feels more consistent. But it's integrated in Rust, so there it is. A last couple points. One on API stability. If you want your crate to stay popular, try not to do the Angular thing of breaking your API all the time. There are a few things to take into consideration. When you make a type public and you make every field of that type public, that means that adding something or changing representation in memory is a breaking change. So unless you're really sure you don't want to change these things, ideally make things private first. The other thing is that builder patterns are a great way to make sure that you can keep holding API stability, that you want that you can add stuff without destroying your API. So you can just look them up. This is why we use them in Zeno. This is why we're actually removing all the structures that have only public types in Zeno, because we're kind of annoyed that we've made them and now we're stuck with them. And the other stability you can offer your users is ABI stability. This one requires a lot more effort because ABI stability is actually quite complicated to achieve. But what it does is allow your users to pass your types through the FFI boundary without worrying that Rust might have changed how they look from one compilation to another. And it's actually rather hard to do because you need to be sure of how you represent your types. You need to be sure about the invariants that they're going to have to keep kind of forever. But there are tools to do it. One that existed before I came in was ABI stable. Basically provides you with an alternative to the standard library that is ABI stable. And the other one is the one I wrote. It's called Stabby. It actually has compact sum types. It has all the nice things that Rust has. Some of them in a slightly more verbose way because I'm tricking the compiler into being ABI stable. But it works, and it's an alternative to the standard library. So if you want to pass Rust types over the FFI frontier, I advise you to use one of these, preferably mine. Well, that's it. If I've not annoyed you too much, you can check out my other presentations, which are a bit more heavy. First one at RustConf was about what ABI is and what ABI stability is and why it's a nice thing to try and have. The other one is how you can achieve it through Rust type system by doing awful things with the fact that it's actually Turing complete. So yeah, thank you. Any questions on this very, very simple talk? Go ahead.
What is Miri?
So Miri, so the question is what is Miri? Miri is basically a runtime that you can use in Nightly to basically run your code in. It's basically Rust Valgrind. If you've ever used Valgrind on C, it's basically an equivalent. It's going to check for undefined. It's going to check for undefined behavior. So it's going to check whether. So basically, it's going to annotate any memory region with the permissions that you should actually have on it. And if you do an access on it that you shouldn't be permitted to use, it's going to tell you about it. If you try and do an overflowing operation that isn't checked, it's going to tell you about it. All these things. So it's nightly only, but basically all you do is cargo plus nightly Miri, and then run or test or whatever, and you will be running your code inside Miri, which will tell you about any undefined behavior you reach at runtime. Unfortunately, it's a runtime thing, so it can't tell you. It's not a static analyzer. It's not going to tell you of all undefined behaviors that are reachable. It's just going to tell you about the ones you actually reach. Go ahead.
What do you think of abandoned crates that live in crates.io but can't be updated anymore because the maintainer is not here?
So what I think about abandoned crates, I think people should have a right to abandon their crates because it can actually become a ton of pressure. There were some very nice projects that have unfortunately died, including Bus Factor, which unfortunately died because the people doing Bus Factor were bus factored. But the idea behind some of these projects were basically to have maintainers which have no interest in actually maintaining the crate, but have an interest in finding new maintainers if you ever become unavailable to do it. I think that unless you're removing your project because you have some very, very salty feelings, ideally you should try, if you don't want to support your project anymore, you should try and open up to people to tell them, hey, I'm not going to support it anymore, but please take up the mantle. Because it's normal to not want to work on something anymore, but ideally, please don't leave your users hanging. Go ahead.
What do you think about name squatting on crates.io?
What do I think about name squatting? I think it is a horrible thing to do. If you do it, you're a horrible person. I think that crates.io should be getting namespaces because A, it would solve name squatting quite a bit, and B, it would also allow us to have some nice things like visibility tied to a namespace. Because, for example, Zeno, we've split up Zeno in many tiny crates to make the compilation faster, but that also means that we have some types that are public that we don't actually want to be public, but we just have them public because we need to use them in a different crate. Or maybe sometimes we have stuff that aren't where we'd like it to be, but they're here because orphan rule. For those that don't know the orphan rule is that you can't implement a foreign trait for a foreign type. So you can't implement a trait that comes from a different crate than yours for a type that doesn't come from your crate. It's a super annoying rule. I hate it. I know why it's here. I still hate it. Ideally, if you had namespaces, you could relax that rule for things that are in your namespace, this kind of stuff. So I find namespaces would be great to solve name squatting and to get some very nice features for projects that need multiple crates to be compiled in less than 2 hours. Anything else?
Yeah. Quick question. Maybe I should watch the talk before asking this. But for API stability, how do you ensure that the Rust compiler doesn't realign or doesn't change the order of the?
So this is something I talk about a bit in the conference, but the short thing is that basically Stabby, you basically use it through one procedural macro, which is Stabby. You put it on top of anything, and if you put it on top of a type, what I will do is turn it into something that is representation C. I will tell you fucked up if you made it less compact than it should be, and I will turn your enums into basically I will do the niche optimization through type calculus. It is very horrid. You can check out the Rust Lab talk about how it's done. Go ahead.
You mainly mentioned technical reasons on how to improve a packet and get more downloads. Do you have any advice regarding, let's say, create marketing on how to reach more people?
So the question was, do I have any advice, any non-technical advice on making a crate more popular? If I had them, I would have more downloads. But I mean, my opinion is that ideally you should communicate about whenever you do a release, whenever you think you did something worthy, just publish about it on r/Rust or any community that you like that is Rust-centric. Publish about it in the communities that are centric to the topic of the thing. If you do neural nets, publish about it on r/neural nets, whatever. That, and also try and be kind. That's generally the kind of thing that gets people to stay.
Or you can try and find projects that would benefit from your crate and try and PR it, and that will get you tons of downloads and completely undeserved.
So yeah, the other suggestion from someone here is to try and basically insert your crate in a different project that might need it or might not. You can do that. One last suggestion is click farms. Okay, I think everyone is hungry. Let's go for the food now.
Cool.